Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS only and we are focusing on ISS 2026. So as we all know that this time we are celebrating Diwali, I wish you all a very happy Diwali. And now that Diwali is over, we should all come back to our basic, which is our preparation, and that is our only motive from now till June 2026 when the exam begins. So, we have been covering the topic sampling techniques. In that, we have started double sampling, in which we did ratio estimator, estimation of ratio estimator in double sampling, and the MSc of ratio estimator. Today, we'll start with the new topic in that only, which is product estimator. So, like ratio estimator in single sampling was similar to the ratio estimator in double sampling. The only difference was both x bar is unknown. In this also, the predictive values are unknown or the auxiliary variable are unknown. Here also, in the product estimator, the auxiliary variable are unknown. Rest all is similar to that of single sampling. So let us begin. Product estimator in double sampling. So the product estimator is defined as Y bar cap PD, where P is for product and D is for double sampling. It is nothing but Y bar into X bar upon X bar dash, where X bar dash is the unknown value or the predicted value of our auxiliary variable. This is the product estimator. Now, by the approximation up till up to 2 order 2, we have E1 is equals to Y bar minus capital Y bar upon capital Y bar. E2 is X bar minus capital X bar upon capital X bar. And E3 is X bar dash X bar prime minus capital X bar upon capital X bar. Let us consider these. So when we put all the values in the product estimator is given by of double sampling is Y bar PD, which is Y bar into X bar upon X bar prime. Keeping the values, we will get 1 upon E1, 1 plus E1 capital Y bar, 1 plus E2 capital X bar upon 1 plus E3 capital X bar. Here capital X bar and capital X bar gets cancelled and we are left with 1 plus E1 into 1 plus E2 into 1 plus E3 raised to the power minus 1 into capital Y bar. Now 1 plus E3 raised to the power minus 1, if we open this expansion, we will be getting 1 plus E1, let us keep capital Y bar here, into 1 plus E2 into 1 minus E3 plus E3 square minus E3 cube plus up till this. Now, if we are taking approximation up to 2 order, so higher power than 2 will be taken out of it. So we are not considering powers greater than 2. So by multiplying this, we will get y bar into 1 plus E1 plus E2 plus E1 E2. I have multiplied these two, and then I am multiplying 1 minus E3 plus E2, E3 square. Now if we multiply this, we will be getting 1 minus E3 plus E3 square plus E1 plus E2 plus E1 E2 minus E1 E3 minus E2 E3 plus E1 E3 square plus E2 E3 square minus E1 E2 E3 plus E1 E2 E3 square. Now again taking approximation up till second order, we will take only with the power 2, and greater than power of 2 will be avoided. So here this we are ignoring them. So we are left with y bar 1 minus, or we can take it like this, the product estimator of double sampling minus y bar is nothing but y bar into E1 plus E2 minus E3 plus E1 E2 minus E1 E3 minus E2 E3 plus E3 square. This is the thing that we are left. This is known as the bias when we take the estimation. So let us take the estimation. Before that, let us consider this. Estimation of E1 is equals to estimation of E2 is equals to estimation of E3. All these are equal to 0, which we have done in the product estimator as well, ratio as well, and in double sampling and regression as well. Now estimation of E1, E2. We know that estimation of E1, E2 is nothing but 1 upon n minus 1 upon capital N rho Cx Cy. Estimation of E1, E3. It is nothing but 1 upon capital N dash minus 1 upon capital N rho Cx Cy. Estimation of E2, E3. This is nothing but 1 upon n prime minus 1 upon capital N Cx square. And estimation of E3 square is nothing but 1 upon n prime minus 1 upon capital N into Cx square. Right? So now we'll take the estimation here. This is bias, or let us write it first as estimation only. Estimation of product estimator of double sampling minus y bar is nothing but y bar into estimation of epsilon 1, sorry, it is E1, estimation of E1 plus estimation of E2 minus estimation of E3 plus estimation of E1 E2 minus estimation of E1 E3 minus estimation of E2 E3 plus estimation of E3 whole square. Now this can be written as bias of product estimator of double sampling is equals to keeping the values E1, E2, E3 is 0, so I am writing 0 plus 0 minus 0. Estimation of E1 and E2 was 1 upon n minus 1 upon capital N into rho Cx Cy. This derivation we have conducted in the ratio estimator as well, in the ratio estimator of single sampling as well. So if you want to know the derivation behind it, you can see that lecture, or if you have been covering the topic with us, then you know where these have come from. So I am writing here so that you can recheck it. Ratio estimator of double sampling. Now E1 and E3 can be written as 1 upon n prime minus 1 upon capital N into E1 and E3 are rho Cx Cy. Then E1 and E2 is 1 upon n prime minus 1 upon capital N Cx square, and this is 1 upon n prime minus 1 upon capital N Cx square. These two are positive and negative of the same units, so they are cut, and now we are left with y bar into 1 upon n minus 1 upon n prime into rho Cx Cy. This is the value of bias of product estimator of double sampling. Now after the estimation or the biasness, we will check for variance or MSE. Mean squared error of product estimator in double sampling. Now what is mean squared error in product estimator? So mean squared error of product estimator in double sampling can be written as estimation of bias of product sampling, which is estimation of mean of product estimator in double sampling minus y bar, mean of y. So this can be further written as estimation of, now y bar minus this value. This value is this y bar, mean of y bar product estimation in double sampling minus mean of y is y bar E1 E2 minus E3 E1 E2 and all those things. So here if we write the values E1 plus E2 minus E3 plus E1 E2 minus E1 E3 minus E2 E3 plus E3 square whole square. Now we are taking approximation up till order 2. So if we'll take square of this, these are 1 plus 1 which is equals to 2. Square of this will be power raised to the power 4. So we will ignore all these terms and we are left with MSC of mean of product estimator of double sampling is nothing but estimation of E1 plus E2 minus E3 whole square. Now this can be written as estimation of E1 square plus E2 square plus E3 square minus 2 plus 2 E1 E2 minus E1 E3 minus E2 E3. Now we all know that estimation of E1 square is nothing but 1 upon n minus 1 upon capital N Cy square. Estimation of E2 square is nothing but 1 upon n minus 1 upon capital N Cx square. Estimation of E3 square is nothing but 1 upon n prime minus 1 upon capital N Cx square. Estimation of E1 E2 is nothing but 1 upon n minus 1 upon capital N rho Cx Cy. Estimation of E1 E3 is 1 upon n prime minus 1 upon capital N rho Cx Cy. Now estimation of E2 E3 is 1 upon n prime minus 1 upon capital N Cx square. These are the values again taken from ratio estimator. So putting the values in MSC's formula. MSE of mean of product estimator in double sampling, which is nothing but estimation of E1 square plus estimation of E2 square plus estimation of E3 square plus 2 times of estimation of E1 E2 minus 2 times of estimation of E1 E3 minus 2 times of estimation of E1 E2 E3. Putting the values in this equation, we will be getting this is 1 upon n minus 1 upon capital N Cy square plus 1 upon n minus 1 upon capital N Cx square plus 1 upon n prime minus 1 upon capital N Gx square. Now plus 2 1 upon n minus 1 upon capital N rho Cx Cy minus 2 1 upon n prime minus 1 upon capital N rho Cx Cy minus 2 1 upon n prime minus 1 upon capital N Cx square. Now taking the common terms. Common terms is 1 upon, I am taking the terms of including the coefficient 1 upon n minus 1 upon capital N. One is Cy square, one is Cx square, and the other one is this rho Cx Cy. So it will be Cy square plus Cx square plus 2 rho Cx Cy. Next term we are taking common is 1 upon n minus 1 upon n prime minus 1 upon capital N. So it will be Cx square minus 2Cx square, which will be minus Cx square. So let us take common sign as well. We are taking the sign minus here. So it will be plus Cx square and plus rho Cx square plus 2 rho Cx Cy. We are taking this as well. So now we all know that this is the MSC of the product estimator of single sampling, which we denoted by this symbol, and this is nothing but 1 upon n prime minus 1 upon capital N into Cx plus 2 rho Cy. So we can write that MSE of product estimator in double sampling is equals to MSE of product estimator in single sampling minus 1 upon n prime minus 1 upon capital N into Cx plus rho Cy. Now shuffling the terms on right hand side and left hand side, we will be getting MSE of product estimator in single sampling minus MSE of product estimator in double sampling is equals to 1 upon n prime minus 1 upon capital N Cx into Cx plus 2 rho Cy. Now if Cx plus 2 rho Cy is greater than 0, Cx plus 2 rho Cy is less than 0, Cx plus 2 rho Cy is equals to 0. If these are the cases, then what happens? If this is the case, then this is greater than 0, though this is also greater than 0. Hence, we can say that product estimator of double sampling is more efficient than product estimator of single sampling. And if the if it is the other way around, then we can say that product estimator of single sampling is more efficient than product estimator of double sampling. And if it is equals to 0, then both are equally efficient. So this completes your topic, product estimator and double sampling. In the next lecture, we'll start with another estimation, which is regression estimator and double sampling, and that will complete your double sampling. I hope you got what we have done today in the class, and if you have any doubts, you can ask on our WhatsApp channel or in the comments down below. Only relevant doubts will be answered. And keep on working hard, and now is the time that we begin doing the work with consistency. Keep on watching the lecture videos along with the English and GS. All the best. Thank you.